Okay.
Okay, Assalamualaikum. Uh, my name is Muhammad Arif HASHNAN from in subject SECP T223. So we are three. I'm Arif. So then Hakim and also Iman. So title for the project is Uncovering Healthcare Patterns, a data analytic approach with tuberculosis dataset. For the intro, we are using the TB dataset, provide a resource of information to analyze healthcare trends, public health metric, and factor impacting health outcomes. This project aims to explore and uncover patterns within the dataset by leveraging data analytic techniques such as cleaning, preparation, visualization, machine learning. By analyzing this insight, the study seeks to identify key factors driving health disparities and predict potential challenges in healthcare system. Ultimately, this project strives to contribute to a deeper understanding of healthcare dynamics and support data-driven decision making for improved health customer. Alright, so what we want to analyze first, we want to correlation between the household size and eligibility. Second, how accurately can household characteristic, TB incident, and preventive therapy eligibility predict the percentage of children under 5 receiving TB preventive therapy. And the last one is how accurately can the K nearest neighbor algorithm classify treatment eligibility for latent tuberculosis infection based on household contact and previous treatment data. Alright, so we go to the first part, which is my part. Alright, this is the import library. We are using the Panda and the NumPy and also all the extension we use. Alright, so we go to the part of the cleaning. So the code is we use the CSV file located with specified part and using into the Panda data frame. Uh, we also the art prefix ensure backslash in the file part treated in literary. And then we drop column to many with too many missing values. The missing fraction calculates the proportion of missing values for each column. Any column where more than 90% of the value are missing is removed. And then we fill or input missing values. First, numerical column. All numeric column are identified. Missing values in this column are replaced with the median of the column. Second is categorical columns. All categorical columns are identified. Missing values in this column are replaced with the most frequent value of the column. Then we remove duplicate rows. Any duplicate rows in dataset are removed to ensure unique records. Then ensure correct data types and ensure that all numeric column remain to the correct type, which is float 64 or integer 64. Then we print the clean data and we display the first 5 row in the clean data frame to allow inspection of the result. Then we save clean data to the new file and we save a new file at the specified part. Index first ensure that the index column is not greater the file. I think that's all for the part of the cleaning.
So for next part, so this is the data dictionary that we extract from the datasets that Arif just present. So next, we're going to analyze what we want based on the datasets. So first, we will look at the graph. Where total treatment eligible individuals per region. Why we use this graph? It is to highlight which regions have the highest or lowest number of treatment eligible individuals. So why? This will help identify regions that may require more resources or attention in healthcare planning. For example, if the bar for the AFR, which is Africa, region is the tallest, so it indicates that Africa is the most people eligible for treatment lah. So next graph. Which is the average household size by region and year. Can you go a bit below? This is to show how household size varies across regions and changes over time. As we all know that TB infectious, right? So maybe we can see from this graph where large household size may correlate with increased spread of disease and healthcare challenges lah. Next. Next, we will look at the top 3 regions with the most treatment eligible individuals, which is Africa, Southeast Asia, and EMR. We just choose 3. So this graph is to, can you go a bit lower? Is to directly compare the top 3 region with the highest number of treatment eligible individuals. Focus on priority areas for healthcare interventions lah. For each country, which is the most priority. So, for example, if AMR, and Africa are the top 3 regions, these areas may need the most immediate attention for resource allocation. So, next. We have a trend of treatment eligibility over time. Can you go a bit lower? So the purpose of this graph is to track the changes in the total number of treatment eligible individuals over the year from the year of 2015 to the latest, which is 2023, based on the data sets. So it indicates whether the issue, which is TB, is improving, worsening, or remaining stable over time. As we can see, if the line shows a consistent upward trend, so it suggests an increasing need for treatment efforts. So next, for the last part, which is the correlation between household size and treatment eligibility. So the purpose of this graph is to examine the relationship between the household size and the number of eligible individuals. It helps determine if larger household size are strongly linked to higher treatment eligibility. For example, so as we can see the slope here, right? A positive slope in the regression line indicates that as household size increases, the number of eligible individuals also tends to rise. So I think that's for the visualization part. Next, we will move on to machine learning application.
Okay, next we move to part 3, which is machine learning applications. So the first one, we'll make a clustering, K-mean clustering about household size versus preventive therapy eligibility. So basically this graph is used to answer our first question, which is first research question, which is, where is it? Okay, the correlation between household size and eligibility. Okay, so basically from this graph, what we can analyze is we can say that higher eligibility but low coverage suggests area with insufficient resources or outreach efforts. And then the second one is low eligibility but high coverage might indicate efficient use of resources or potentially over targeted areas. So next we move to the second part of machine learning is about we make a, what is this? We make a random forest regressions. So basically this to analyze we want to make a model to predict what is the features that will the most important features that can predict the number of TB infections. So by analyze this graph, we can say that this graph help on understand which variable contribute the most to prediction. The higher the importance, the more the feature affect the outcome. Predicted versus assured. This plot ideally show point closely aligned along the diagonal red dashed line indicate accurate predict. So inside on this random forest regression is new week core 04 underscore private TX. Now maybe highly important indicate the number of children aged under 5 started on TB preventive therapy who are household contact of the TB cases in the new ins underscore core privated is the strongest predictor of the therapy coverage. Okay, next we move to the last part is KNN classifications. So by this KNS classification is also to make a predictor model. The target is a binary classification target. The target derived from E-pre-TX eligible is greater than 25,000. If this is greater than 25,000, the target will show 1, otherwise it is 0. So variable like household size and number of household contact are likely related to the spread and the history of the tuberculosis TB, which influence the number of individual eligible for preventive treatments. The previous treatment data availability and percentage related to previous treatment are strong indicator of how many people are at risk or have been treated, directly affecting eligibility. So by see at this model, we can see that accuracy is 0.98. So we can say that it is near to 1. So we can say it is quite relevant model lah. Okay, next we move to the last part, which is conclusions. The conclusion that we can make from our project data analysis programming is the k-means clustering show different group based on household size and the therapy eligibility, which helping identify target areas. The random forest model show that the household features strongly influence the percentage of children getting therapy, and the KNN classification accurately predict whether a household is eligible for therapy based on various factors. So I think that's it from our group. So thank you.